Okay, so if you want to add two vectors, and adding two vectors is very important in this course because when you get the total force on a charge or the total electric field at a certain point in space, you're going to be adding the electric field due to each charge. And so that means you're adding vectors. So you need to know how to add vectors properly. So let's say you have a vector A, which has an x component ax and y component ay. And you have a vector B, which has a component bx and by for the x and y components, bx and by. And you want to add these two vectors. How would you add them algebraically? Algebraically, you just put all the components and then you combine the ax and bx in the I direction and the ay and the by in the j direction. Means you get something like this. So you have ax plus bx in the I plus ay plus by in the j. And so that gives you the sum of the two vectors. So you add the x components and you add the y components together separately. If you want to do this graphically, you can also take the vector A, keep it as it is, and take the vector B and shift it, keeping the direction the same, so that the tail of B is at the head of A, and then draw one vector that points from the beginning of A to the end of B. And that vector will be the sum of the two vectors. So let's see why that works. If you take vector A, it has an x component ax, and the vector B has an x component bx. So the total x component now of the new vector is ax plus bx, which is what it should be. And the y component of the new vector is by, this distance is by, plus ay, so which is what it should be. So the vector C satisfies the requirement that you're adding the x components and you're adding the y components, so it works out graphically too. Try to look at this simulation. It's a nice simulation on the PhET website about vector addition, and you can do that on your own.